Before we start the podcast, we wanted to let you know about WestOS. If you're a teacher or pupil at a school in Scotland, then you now have access to hundreds of quality assured video lessons created by teachers to support your remote learning. You should be able to find WestOS within the app library of Glow, where you can add the tile to your own personal launchpad. Click on the tile and you'll have immediate access to stream lessons in every area of the Scottish curriculum, with video lessons already available for biology at National 5, Higher and Advanced Higher. Now let's get on with the podcast. This podcast is sponsored by Lecky textbooks, revision guides and practice papers. Everything you need to learn, review and prepare for your SQA exams. Browse the books at www.leckyscotland.co.uk and get 40% off using the discount code LeckyPodcast40. And to celebrate the new school year, we'll be giving away copies of some amazing Lecky Higher Biology books on our Twitter page, @BiologyHigher, where you can find out how you can get yourself some free books.
Chimps are our closest relatives, and so why are people surprised that they express their emotions the same way as we do?
In this podcast, we will hear the story behind Mama's Last Hug, a YouTube clip which has had over 11 million views. We will consider what politicians can learn from animals and discover how offensive it really is to tell someone they have the memory of a goldfish. We'll be referring to the SQA course specification for higher biology and helping you to understand some of the key concepts. We will learn about the complex behaviours that exist in groups of animals, and to help us work through this social behaviour topic, I'll be joined by one of the world's leading primatologists, Frans de Waal, and Dr. Mike Webster, a lecturer in behavioural and evolutionary biology at St Andrews University. Animal behaviour is an interdisciplinary field of science that examines the interactions between behaviour and biology. In this podcast, we are going to look specifically at social behaviour. Social behaviour characterises the interactions that occur among individuals. The range of social behaviour is best understood by considering how sociality benefits the individuals involved. Many animals live in social groups and have behaviours that are adapted to living in a group, such as social hierarchy, cooperative hunting, and social defence. Before we get started, let's meet Frans.
I am Frans de Waal. I'm a Dutch biologist who lives already a very long time in the United States. I live in Atlanta, Georgia, and I've worked all my life with primates, mostly with chimpanzees, bonobos, and other primates. My interest started with interest in animals, and as a boy, I would go fishing, not fishing for food, but I would catch salamanders and sticklebacks and all sorts of animals and bring them home and try to keep them. And initially, I was very poor at that, but later I became very good at it. And so I already observed at the time the zigzag dance of the stickleback, which is the courtship display, which later, as a student, when I became a student in biology, I learned that this was a very important behavior that many people had studied. But as a kid, of course, I didn't know that. And so I was very interested in animal behavior. I had jackdaws also, which you also have there in Scotland, I'm sure. So I had all sorts of animals. And then when I finished my high school, I went to the university to study biology. And it's only by accident that I came to the primates. Of course, as a kid, I never had any primates, and I'd only seen them a few times at the zoo. And by accident, I met a professor who worked on the primates and who worked at the Arnhem Zoo, where they have this large chimpanzee colony. And so that's how I came into the primate studies. And then later, I moved to the United States. At that time, there was about the time that I did my PhD in the Netherlands, and at that time there were no jobs in Europe for people like me, and there were jobs in the United States, and so I went there, and since that time I work in the US.
If you were doing your biology exams this year at school and thinking about going on to university and possibly had an interest in biology as a career option, what lessons have you learned that would be valuable to our students?
Well, if students are interested in human and animal behavior and comparing the two, or animal behavior in general, in the UK there are many opportunities. I would say you do either psychology or biology. Both of them will get you in the right direction. There are excellent programs, for example, in St. Andrews. There are many professors who study animal behavior and animal cognition, and that's in Scotland. So Stirling and St. Andrews, I think in Glasgow maybe a little bit less. But I would go the route of psychology or biology, and then focus on classes that relate to animal behavior.
And as it happens, we're also joined by another leading expert, Dr. Mike Webster from St. Andrews.
So I'm Mike Webster. I'm a lecturer in biology at the University of St. Andrews. I teach a range of biology, evolutionary and behavioral biology, with a particular focus on animal behavior. And my research is concerned with basically how and why animals hang out in groups, and the costs and benefits of grouping with others. Where do I come from? I did my undergraduate degree in Kiel in England, and I did my a master's in Leeds and a PhD in Leicester. At the time when I was an undergrad, I was kind of torn between doing physical geography. I was quite into glaciers for some reason, and I did biology and geography together. And somewhere along the line, something went wrong, and I ended up doing the biology half rather than the geography half, and here we are.
And of course, there's so many overlaps between biology and geography. Biology is, of course, the study of living things, but those living things live on the planet, and I guess that's what geography looks at.
Yeah, it's quite a nice combination. I mean, you can think of ecosystems, right? And the geography, the physical geography half of the my degree, my undergraduate degree, and the biology half, they've been meshed together pretty nicely. It's quite a nice sort of coherent package, I guess.
So obviously you spent a lot of time working and looking at social behaviour and particularly animals that live as part of social groups. What are your favourite social groups that you've worked with?
That's a good question. I've always found fish schools fascinating. This is kind of how I got into biology, I guess, as a kid. My father was in the Air Force, so we grew up all over the place. Lived in a few air bases in England and a few up in Scotland as well. And actually, I really got into biology and sort of poking around in dirty, muddy water when I was a kid, when I was living at Lucas, a few miles from where I actually work now. And we used to play in this forest, and the trees in there had fallen over. It was quite boggy, and so every time a tree fell over it, its roots scooped out a big chunk of earth and left this pond about 6 or 8 feet across. And when I was about 8 years old, I used to duck around in there looking for tadpoles and looking for diving beetles and things. And then we found the ditch nearby had sticklebacks in big schools of fish, and I kind of became a little bit obsessed with fish after that, digging holes in the garden and putting in ponds and catching these fish and putting them in. And somewhere along the line, I've managed to turn that into a paying career, which is pretty good.
Which is a wee bit of a theme, because we've just heard from Frans de Waal, who also puts fishing for sticklebacks and various small fish, not for his dinner, of course, but just generally as a child out of interest.
Yeah, I think it's a bit of a rite of passage. I certainly wouldn't eat anything that came out of the water that I used to duck around in when I was a kid. It was pretty grim. But yeah, I guess some people move beyond that to sort of bigger, more exotic animals, but I never really did. So I mostly studied schooling fish, I guess, for most of my career. When I was a master's student as well, I also did a little project on giraffes, and that was pretty cool as well, studying herds of giraffes as they moved around between different parts of the grassland where they lived in Kenya. So I spent a month or so doing that on a field trip as well, and that was pretty good. But I think what I'm really drawn to is the kind of hands-on experimental side. You know, with animals like that, you observe them, you don't have much control. I maybe didn't realize it at the time, but I've come to realize it since, that what I enjoy most about this kind of science is the kind of pottering and the inventing and the building experimental equipment away in the lab. You know, that's as much as the animals themselves. I think that's my favorite part of the job.
I guess that, again, that stems from that curiosity that you had as a child, and you've never really let that go. Yeah,
I think so. I think that's right. I think it's, if you can take something that you're really into and if you can find a way of turning it into a job, I think it's a bit of a recipe for happiness, I think.
So I guess fishing for sticklebacks has really inspired yourself and Frans to go on and make a career out of that. What can you tell us about sticklebacks?
Well, there's nothing intrinsically special about sticklebacks, right? It's strange. They're a really widely studied species. They're what we call a model organism. So you can think of them a bit like a white mouse or a fruit fly. And I mean, they're so well studied that they've been studied for decades, maybe getting on for a century. They actually have their own international conference. I went to the International Stickleback Conference a couple of years ago in Kyoto, in Japan. In a couple of years' time, it's going to be in Iceland. It's an international conference. And it seems really weird, right? They're not worth any money. There isn't a £1 billion stickleback fishing industry. We don't keep them as pets. They could disappear overnight and most people maybe wouldn't notice. So why do people study them? And the reason is because if you're interested in ecology and evolution, they're a really great, what we call a model system. And that's because they live in a whole range of different environments. They live in the sea, they live in freshwater, they live in rivers, and they live all around the sort of the colder parts of the northern hemisphere. So I've studied these population that lives in a stream right next to our lab in St. Andrews. It's literally 2 minutes walk away. But I've also studied these in Japan, and I've studied them in Alaska and places like that as well. And so you'll find them all through Northern Europe and Northern Asia. You'll find them in North America as well. And so we've got these populations living in areas which, until relatively recently, were covered by an ice sheet. And as the ice sheet retreated over the last few thousand years, these rivers and streams and lakes have become uncovered again, and they initially had no fish in them because they were covered by ice. And the sticklebacks have recolonized them from the sea, from this kind of ancestral marine population. And they move into these different environments, and they begin to evolve in all sorts of different directions because they face different selection pressures. Some have different salinities to tolerate and deal with. Others have different predators, for example. And you can find different populations with a similar kind of selection pressures acting on them. And you can study these populations and you can get a really good idea of the kind of things that shape evolution.
Do we see any sort of social interactions amongst sticklebacks or other schooling fish?
Oh, yeah, absolutely. So they're what we call facultatively social, the free-spine sticklebacks. There's actually several species. So facultative means that they don't have to live in groups, but they often do. So when you look at them in the river, you'll sometimes find them by themselves. Sometimes you'll find them in big groups of tens or hundreds or even thousands. And their behavior changes over the course of a season as well. So they have a distinct breeding season. They only breed in the springtime. And when they do, it's the male who looks after the young. So the male will build a nest, and he becomes quite antisocial, and he stops shoaling, and he'll chase away other sticklebacks, particularly males. And once a female comes and lays the eggs in the nest, he'll actually guard them. So he'll look after them. He fans water over them to keep oxygenated water flowing over them, and he'll look after the babies while they're young until they're big enough to fend for themselves. So while he's doing that, he's quite antisocial. But at other times of the year when they're not breeding, they form these quite big schools. And it's a schooling aspect, really, but I'm interested in their behavior. So I mentioned the evolutionary work before, and I have some students who are interested in that. But it's really the social behavior and how and why they form groups and how they use information from one another that interests me and that drives my research.
Let's go back to Frans, who has written some infectiously good books, and he shared the moving story behind one of these. I had the privilege of reading your recent book, Mama's Last Hug. And of course, that's not about giving your own mother a cuddle, is it?
No, it's about a chimpanzee named Mama. And at the Arnhem Zoo in the Netherlands, who has been the alpha male of the group for 40 years. Alpha female doesn't necessarily mean that you dominate everything, because there's usually an alpha female and an alpha male. And in chimpanzees, the males are dominant over the female. But Mama was very powerful. I always make that distinction. She may be in rank below the males, but in terms of power and influence in the group, she was really number one, I would say. And since she was so influential in the group and so central, and also connected with humans very well, much more than the other chimpanzees, my professor, Jan van Hoof, who was 80 at the time, went to say goodbye when she was dying. She had been put in her night cage. She was 59. She was clearly gonna die. And so he went in with her, something that we normally never do. And this is a video clip that you can see on the internet.
And it's quite a powerful video clip.
Yeah,
It's been seen by millions of people. And actually what your professor did at 80 years old was pretty brave, because my understanding is that chimps have kind of got the arm strength of 5 times the human arm strength if they're male, and kind of 3-4 times the arm strength if they're female. So that's quite a brave thing to do straight away.
Yeah. So he He did that as an exception because we normally would never do that. But since he was so weak and since he had known her for such a long time, he risked that. And then they embraced, and that's all on the video. And the reason I took that video clip, which went viral as the title of the book, Mama's Last Hug, is because people were so surprised by it. That people were emotionally affected, I could fully understand. Anyone who watches that is emotionally affected. But people were also surprised how human-like her expressions and her gestures were. And that is something that surprised me, because we've been saying for 50 years, chimps are our closest relatives. And so why are people surprised that they express their emotions the same way as we do? And so I felt I needed to explain that all the facial expressions that we have and all the gestures and almost everything we do is primate-like, except our language. That's the only one where I make a difference. But for the rest, our whole body language and our psychology and our social relationships and our emotions, all of that is extremely similar. And that was expressed in that video clip. And so that's why I took that as a title.
And Mama herself, she would have been 59. She was a good old age for a chimpanzee.
Yeah. They sometimes go up to 75, I've heard, but I don't believe those stories necessarily. They don't come from reliable sources, but I would say 60. 60 is the age limit for a female. For males, it's a bit younger. Males usually die a bit younger than the females, just as in our species.
Within primates, complex social behaviours are learned from parents, and that takes a long time. Frans went on to describe parental care in a little bit more detail.
Parental care in the apes is very much a female business. So the females take care of the offspring. They also produce the offspring, of course, and then they nurse them. Now, the nursing part is mammalian. All mammals, the female needs to be involved in the early care of the offspring. The male cannot do the nursing part. And so that's obligatory for the female. And parental care is sort of optional for the male. In chimpanzees and bonobos, the males do very little. But there are, of course, many species where the males are more involved. And if you go to the birds and not just the mammals, then males are even more involved. And so male involvement in caring for the offspring, it happens in quite a few species, but in our closest relatives, it's mostly a female business.
That parental care obviously takes place over a long period of time, and that's very much to allow the learning of complex social behaviours to take place from the parents to the offspring.
Yeah, but it's also because the offspring are very dependent, and they're nursed for a long time. So, for example, chimpanzees and bonobos, they nurse for 4 years. Orangutans may even nurse for 7 years or 8 years. So the young ones stay little for a very long time. And a chimpanzee, for example, chimpanzees and bonobos are our closest relatives. A chimpanzee is adult when they're 16, 15, 16. So there's an enormous amount of development, and they learn a lot. Because people sometimes think that everything that these other primates do must be instinctive. But of course, there's an enormous learning period, just as in our species. And the word instinct we barely use anymore, because instinct has this implication that a behavior is genetic. It's sort of pre-programmed. And that kind of behavior barely exists in many other species. And in our species also, we don't usually talk of instinctive things.
Primates, including gorillas, chimpanzees, monkeys and humans, are organised into a social hierarchy that determines access rights of an individual to food, mates and habitat. Complex social behaviours have developed to support this social hierarchy, which is why this extended period of parental care is required, as it allows time for these behaviours to be learned from parents. Frans went on to tell us more about some of these complex behaviours, including ritualistic displays, which are often used to reinforce a leader's position within a group and can reduce conflict.
Yeah, ritualization is a very old concept in ethology, and all animals, when they fight, they are ritualized fights. It's very rare that they fight all out to kill somebody else. That's a very unusual thing. Most of the time, so even snakes, even venomous snakes who could kill each other by biting each other, they slam their bodies together. All the animals have ritualizations, and for example, the wolf and the dog, they don't usually bite here in the throat or in the belly. So there are certain places where they usually don't bite because everything is ritualized. And so the ritualized fighting, like the chest beating of the gorilla, also that's also a ritualization, serves to warn the other that you are strong and vigorous, and you better be careful. And hopefully that way you can avoid a fight. Then, because that's much better if you can get your way without a fight, is better for the winner, is also better for the loser, and so it's better for everyone. And that's why these ritualizations exist, and we find them in all species, basically.
My understanding is, Frans, that in your early career, you started off at looking at aggression and fighting among animals, but actually that quickly led on to looking at reconciliation between animals.
Well, reconciliation occurs in many species. I discovered reconciliation long ago in the chimpanzee, meaning that chimpanzees, after fights, they kiss and embrace each other, and then they groom each other. And so they repair the relationship. But now we know that reconciliation occurs in, basically every social animal, like elephants and wolves and dolphins, and all social animals have some form of reconciliation after fights. And that is because they have conflicts. Conflicts are inevitable, but they also have social relationships on which they depend. So their survival depends on having friends who support them. And so, they need to reconcile after fights, otherwise they lose these friends. And so it's the same dilemma that people have. Of course, people have sometimes fights with their best friends, and you want to avoid that, or you want to repair them afterwards.
And is there a difference between male and females when it comes to reconciliation and fighting?
Yeah, the males are much more violent usually, and the numbers are actually very different, very similar for humans and chimps. There's a paper that came out recently about lethal fights, so killings among chimpanzees in the field, and it's 4 out of 5 is done by males, and 4 out of 5 of the victims are males. And the same is true for human society. And so violence is much more a male thing. Reconciliation, the odd thing is that males are also very good at reconciliation. So for example, male chimpanzees, and I think the same is probably true for human males, is they are friends and rivals at the same time. And so once they have gone through some sequence where they have a confrontation, they're quite ready to reconcile after that. And the females, much more difficult. The females hold grudges, but they have very few fights, and so it matters maybe less, but they don't reconcile very much.
Politics is basically any set of activities that are associated with making decisions in groups or other forms of power relations between individuals, such as the distribution of resources or status. It's easy, as Frans went on to demonstrate, to find examples of ritualistic displays and other social behaviour in our own human politicians.
Well, I found it so interesting that Trump was very good with, because in the primaries in the Republican Party, there were like a dozen candidates, and Trump was very good at intimidating them and insulting them and having nicknames for them and walking around with a big swagger, like a big male chimpanzee, basically. He was very good with that. But then he faced Hillary, who's a woman. And the rules for confrontations between males and females are totally different from between males and males. Between males and males, we know you have to stand up and deepen your voice and act tough. That's not how you deal with a woman. At least you're not supposed to. You're not supposed to base it on strength. And Trump was trying to do that. He was trying to play on his size and strength like a male politician. But it didn't go over very well, and it was not received very well that he was trying to walk behind her and look intimidating. That's not how we want males to deal with females. And so I found it interesting that he did not understand, or did not fully understand. He understood that he could not do the same thing, but he was trying to in some way.
And that idea of an alpha male and an alpha female, that's an expression that possibly can be traced back to one of your previous books.
Yeah, I wrote Chimpanzee Politics, which is all about these strategies. And of course, the term alpha male partly comes from that book, Chimpanzee Politics, and was adopted in Washington and then beyond. I don't know if you people call Boris Johnson the alpha male. I don't know if you use that terminology, but here we use that kind of words.
I'm not even sure where to start with that, Frans, to be honest, right now. What would the difference between an alpha male and an alpha female be? Are there differences?
The alpha female is the top female of the females. The alpha male, the top male of the males. That's how it is defined. So you always have an alpha male and an alpha female. You don't have more than one in a group. And they're the male and the female spheres are to some degree separate. So the females have their business and the males have their business. Sometimes they meet. The alpha female usually in a group of chimps has more a binding function. For example, she may mediate after fights. Let's say the males cannot reconcile after the fights. She may actually bring them together. So she has this sort of binding function in the group. The alpha male, usually more top down in the sense that if there is a fight, he steps in and he stands in the middle and he beats the parties apart to make sure that they stop fighting. So he's a bit more heavy-handed in his because he's the dominant male. So they have quite different strategies, but they can both be extremely influential in the group.
And what would the advantages of social hierarchy be?
Well, it usually reduces aggression. So I know people are sometimes upset and they say hierarchy is not good. And so I think hierarchy is absolutely essential under certain circumstances. That's why the military has a hierarchy. And that's why in the operating room in the hospital, there is a hierarchy. You need hierarchies to make quick decisions. And so hierarchies are essential for cooperative enterprises, and they reduce conflict. So the first moment when, for example, young goslings meet, or young puppies, or young children in the daycare centers, the first day when they meet, there's quite a bit of fighting and jostling going on. But once the hierarchy has been established, which happens in a day or even sooner, once it is established, all that aggression goes down. And it actually, in the end, it prevents aggression because the encounters become predictable between them. So it is a device to reduce open conflict.
And of course, it would also increase the chances of a dominant animal's favourable genes being passed on to offspring.
Yeah, that is a consequence of the male hierarchy. The males compete over who can mate with females. And in some species, of course, males have many females. In other species, it's just the alpha male does a little bit more mating than other males. So yes, for the males, that is competitive business about mating. For females, it's more about food. Females don't gain by mating more. They need to mate with a good male and that's it. So they don't gain from mating with more partners, but they gain from having better food. And so for females, it's often food oriented.
And then if the formation of alliances within hierarchies would help individuals increase their social status within the group.
The social relationships, in many primates, there are kinship relationships. So the females, they have their daughters and they have their sisters and their grandmothers and all these females who are relatives from each other. They support each other. So that's a very important part of many primate groups, is the kinship network of the females. But the males may have coalitions which are a bit more opportunistic, and they help each other. And so a male may become dominant because he has a buddy who helps him. And they usually then, these males will groom each other quite a bit and hang out with each other quite a bit. And in addition, since the dominant is then dependent on his buddy, he needs to hang out with him because if he's ever found alone by a rival, who knows what's going to happen. So that fosters relationships. And so these alliances are very important, certainly in chimpanzees, very important. In bonobos, interestingly, it's a female. The females are dominant. And that's based on a female alliance. So the females support each other each time they see a male who is not behaving the way they want him to behave. They support each other against that male. And so the females are collectively dominant. They're not individually dominant, but collectively dominant over the males.
Let's go back to Mike and start by asking him what lessons our politicians and all of us might learn from animals.
Well, to be careful here not to offend any of the animals. I think that we tend to put too much stock in prominent or outspoken individuals and their opinions. I think we would do an awful lot better as a society at making decisions and sort of at a political level making decisions if we took information from a broader range of sources and weighed it more carefully. So we often see that people who have maybe by whatever measure been successful in one particular job suddenly find themselves running another organization which is completely unrelated, and it's assumed that they will do an equivalent job there, and that's really not the case at all. I mean, I don't know how deep we want to get into the sort of political side of things here, but we've seen with the government's handling of COVID, for example, that they had access to a panel of scientists and advisors and people who have a background in public policy and kind of shaping policy and shaping behavior, and they've largely, it would appear anyway, largely been ignored, and the government's basically done its own thing. By the government, I mean Westminster here, not up here in Scotland, where we've seemed to have done a much better job of handling things. I'm not sure I can necessarily relate that back to an animal kind of example, but I think that's something that humans do that animals generally don't, right? Is that we take our lead from whoever's making the most noise, or from whoever appears to be the most confident. My work with sort of groups of animals, like groups of fish, for example, how they process information, it seems to be a much more egalitarian way of doing it, and information from lots of sources is combined and weighed, and the best decisions kind of flow from that rather than from some more directed top-down leadership.
I guess that's something for everyone to strive for, that wide approach to gathering information and making sure it's coming from multiple reliable sources rather than just relying on the first thing that maybe we see on social media or whatever.
Well, exactly, yeah.
Having access to reliable information is vital in all aspects of our daily lives, and not just something we should consider when writing school assignments. I was keen to further explore Mike's work with fish and learn more about an example of cooperative hunting on page 180 of the Lecky Higher Biology student book, showing bottlenose dolphins working together to block the path of an oncoming shoal of fish and how those fish react.
They react by they react very closely to the behavior of their neighbors, right? So when you see these schools of fish which are being chased by predators, so think of a bait ball of fish on David Attenborough, you've got this big swirling mass of fish. They're able to change direction very, very rapidly, okay? And that confuses predators like dolphins. Dolphins find it hard to pick out individuals when they're all behaving in the same way, okay? So dolphins are really looking to block that group, and sometimes dolphins will swim through the group and try and shear individuals off, because when they're on their own, they're very vulnerable, okay? But when the fish are in a group, they can respond very closely to one another, and they can very closely match one another's behavior. And that means they can do things like change direction and move away from predators, even if the fish themselves can't see the predator. So if the predator is some way away and it's attacking the edge of the group, you'll get this ripple of movement that will pass very quickly away from a group. And that means that individual fish don't even need to see the predator coming to be able to respond. And so the fish's defense against predators like dolphins is safety in numbers, and they engage in what we call collective behavior, okay? And this can confuse the dolphins. So we have this thing called the confusion effect, which basically means predators find it quite hard to pick out an individual prey against the background of others, particularly if those prey all look the same and if they're all moving in the same direction and moving in the same way. So this confusion effect is what the fish are really relying on to escape from predators such as dolphins.
And I guess that's really a form of social defence. Within the higher course, we talk about social defence as allowing some individuals to watch for predators while others can forage for food. But I guess that sort of idea of not necessarily being able to see the predator but being aware of it from your neighbours is another example of that.
Yeah, that's right. So in some groups of animals, it's much more, that kind of collective defense is much more structured. So I think meerkats, for example, and groundhogs, animals like that, will sometimes have an individual on lookout. So they'll be scanning the horizon looking for predators which come on the ground, or maybe looking up in the air for predatory birds of prey as well, which will come and attack them. And they produce different alarm calls. Some species even produce alarm calls which are specific to the type of predator which is approaching. So I think prairie dogs, they produce one type of call which means a coyote's coming, and if a coyote's coming, then you get down the hole. They produce a different one if a badger's coming, because a badger can follow them down the hole, it can dig them out. And they have a different one again if a bird like a hawk or an eagle is coming, which is going to attack from above. And I think this is known from some monkeys as well. Some species of monkeys have alarm calls which are particular to different type of predators, and I think meerkats do this as well.
Mike went on to give us another example of cooperative hunting in fish.
Some friends of mine have done some pretty cool work studying how sailfish attack bait balls of sardines. And they were actually...
I do like a sardine.
Yeah, sardines on toast is a pretty good thing.
It's a pretty healthy snack. What can you tell us then about the cooperative hunting that takes place there?
Well, it turns out that the sailfish, they also really like a sardine as well. And they'll corral these sardines up into these big balls I described earlier, where the sardines are all closely, they're swimming very closely to one another and they're reacting to one another, which means that they can escape from the sailfish when they attack pretty easily, right? These escape waves can rapidly spread through the group and they can very easily get away. And one of the ways that the sailfish overcome this is to take turns to swim into the school. Okay, and this causes the school to scatter and split up. And when that happens, inevitably, some individuals, they're not able to get back in the school. And other sailfish who are hanging around on the margins, they can pick those ones off as they come out. So it's not a form of true cooperation, I don't think, but the people who've worked on this have called this proto-cooperation. So individuals which lunge into the shoal, they don't actually get the sardine themselves. It's those others which are hanging around on the edge which get the sardines, which get scared away from a group. But because everybody takes a turn doing that, everybody gets to feed on some of the sardines.
And that, of course, reduces the competition between those individuals.
That's right, yeah, and it maybe increases the amount of food that they would get compared to if they were just to behave individually, if they were not to coordinate their behavior, and if they were just to turn up and ignore what everyone else was doing and just plowing for themselves, would actually be less successful as a group.
Absolutely. Within the higher course, we would talk about cooperative hunting as benefiting subordinate animals as well as the dominant ones, as obviously they may gain more food than by simply just foraging alone.
Yeah, that's right. I mean, sometimes this emerges as a kind of a happy coincidence. Animals are still behaving selfishly. They're doing what's best for themselves. It just happens that the situation which is best for themselves can also be better for others as well sometimes. There's quite a nice paper that came out a couple of years ago where these researchers studied how wolves hunt as well. So wolves are thought of an animal which hunts cooperatively. They'll surround prey, but it's actually been shown that they don't need to coordinate their behavior at all through simple interaction rules. This kind of cooperative-like hunting can appear, so they end up surrounding the prey animal on all sides and preventing it from escaping. And they don't need to be particularly clever in order to do this. They don't need to know what the other wolves are thinking or doing. Right? They can do this simply by spacing themselves optimally and reacting to where the others are standing. So by following these very simple rules, this quite complex behavior can emerge, and it appears to be quite an effective way of hunting as a group.
Our conversation about cooperative hunting led to a look at other cooperative behaviour between animals. So let's go back to Mike as he shares some examples of altruism and kin selection.
The best examples of kin selection are going to come from groups of animals where you have maybe cooperative breeding. Okay, so the ultimate example of this is the eusocial insects. Okay, so things like ants and bees and wasps and termites as well, where you have one or only a few individuals within a colony who are reproducing, and most of the other individuals in the colony are going to be the daughter offspring of the queen, and they don't reproduce themselves. Okay, they forego reproduction. Instead, they look after their siblings, their sisters, who are produced by the queen. We see something like this, not to anything like the same extent, in some mammals and birds as well. They'll engage in cooperative breeding, and so imagine a particularly harsh environment, and you're a bird like a babbler or a mammal like a meerkat. Okay, you maybe need to defend a very large territory if you're going to be able to successfully raise young, and you need to be able to find food within that environment. And it's very dry, it's very hot, so there's not much food around. So it might be that a pair of parents can't raise the young by themselves. And similarly, if their young do survive and grow up, they're not going to have much success themselves if they go away and try and breed independently. And so you get a situation where you have a dominant pair and their older offspring from previous years, instead of going their own way, will stick around and they will help raise their brothers and sisters who were born in this year. And so they'll do that by defending the territory, and they'll do that by going out and catching food and bringing it back to those young and helping to raise them. Some animals like meerkats, they take this to an extreme. So there's actually a nice example of teaching behavior in meerkats. So one of the things that meerkats like to eat are scorpions, and scorpions are obviously dangerous. They've got big pincers and they've got a big sting as well. And a baby meerkat getting stung by a scorpion, that's quite a big deal. It's going to be very painful. It potentially might be fatal. So the older brothers and sisters will actually teach the young meerkats how to hunt these scorpions. So they will bring one back, and when the pups are very young, we'll bring a dead scorpion back, and they'll let the pups play with it and figure it out. When the pups get a bit older and a bit more proficient at handling these scorpions, they'll bring one back, but they'll bite the sting off. So the scorpion can run away, and it still has to be handled right, but it can't sting the pup. And if the pups are doing particularly badly, then the older brothers and sisters actually bite some legs off so that the scorpion can't get away. And when they think the pups are up to it, they'll bring them back an intact scorpion with a sting. Okay, and if the pups are doing badly again, they can remove the sting. So they're quite sensitive to how well those pups are doing. And the researchers who discovered this, they did this really cool experiment where they figured out that the pups have different calls which change as they get older. And so if they got some young pups and they played back the calls of older pups, then the helpers treated them as if they were older pups, and they brought back more intact scorpions. And if they had older pups and they played back the calls of younger pups, then they brought back more damaged scorpions, which were maybe more suitable for younger pups as well. So there's quite a bit of feedback going on between the kind of the pupil and the teacher, if you like, and that's how we teach them how to handle these quite dangerous and difficult to handle prey species.
Yeah, we're not allowed to bring scorpions into schools these days, unfortunately. So
shouldn't be feeding them either to their pupils, I guess, right?
No, probably not.
Think sausage rolls and houses.
We obviously talk about altruism being the term used to describe behaviour that harms the donor individual but benefits the recipient. And the chances of survival are increased for the recipient but decreased for the donor. And that debt may or may not be repaid later on. Yeah,
so there's one nice example that I can think of, back to fish again, I'm afraid. Is
nothing wrong with that.
This behaviour called predator inspection. So little fish, in this case, things like sticklebacks and guppies, another quite widely studied organism. They're small fish and they're a tasty snack for much bigger fish. So they have lots of predators. The thing is, in their environment, they come across predators all the time. Some of the rivers where we work down in England, there are pike and perch which feed on the sticklebacks, and you walk along the riverbank every couple of meters, there's another pike. And so basically these things are swimming past predators all the time. So if they were to just stop what they were doing and swim away and hide every time they saw a predator, they wouldn't get anything else done, right? They'd spend the whole time hiding. And at some point you've got to go out and look for food and whatnot. And so one of the things that these animals will do is they will look at the predators and engage in a behavior that we call predator inspection, where they'll swim up to the predator and they'll try and figure out if that predator's hunting. So if that predator doesn't respond, if the predator's just having a rest, then you don't need to swim away, right? You don't need to take evasive action because the predator at that time doesn't pose a threat. But obviously getting that information in the first place is quite risky because it means approaching a predator, which is quite dangerous. And for fish, a lot of the way predatory fish feed is they just open their mouth really wide and it creates a bit of a vacuum and it sucks in water. So if you go anywhere near the front of that fish, all it has to do is kind of yawn and you just get inhaled, and that's that for the guppy or for the stickleback. So what they'll do is they'll often approach from the side, so they're away from that dangerous area where they can be sucked in, but they're still approaching a predator. It's still dangerous. And so sometimes they'll do this in pairs, and they will take turns approaching. So one will approach a little bit and then stop, and then the other one will catch up and maybe go ahead a little bit. And so you can kind of think of them as a pair of feet, one walking in front of the other, okay? And they take steps to approach. And that's a form of cooperation, because if one fish swims away and leaves, and we call that defection, then the other fish is suddenly on its own and it's in a lot of danger. And so it's been suggested that this kind of pairwise predatory inspection behavior is a cooperative venture, that they are cooperating with one another to do this, and it's a form of altruism. And there's actually at least one study which suggests that fish might punish partners who cheat on them by not inspecting with them again. So we did a really clever series of experiments, these researchers, where they set up a mirror at a 45-degree angle, and a fish swam towards a predator and it could see its own reflection and presumably thought it was another fish. But because it's looking at its reflection in a mirror which is angled, the other fish begins to deviate and its reflection actually swims further and further away as it approaches. Okay? So it looks like they're cheating. And so those fish, they tend not to inspect quite so much with a partner again. And in another experiment, they had them moving down little corridors, separate corridors towards the predator, and they put a glass partition in one. So one of the fish could only approach halfway and then it couldn't go any further. Okay, and when they took the fish which had been cheated on, the fish which went all the way, and they gave it a choice of inspecting with that partner or with a different partner, they actually found out that it was less likely to inspect with the partner who had cheated. So it seems to suggest that they can remember which individual is rich, and they can remember which individual cheated and which individual didn't, and they prefer not to inspect with the cheaters.
Wow. I always remember as a child having goldfish that we were constantly told that goldfish had something crazy like a 5-second memory. That might not be the case then.
Yeah, definitely not the case. Actually, goldfish have been shown to be able to remember the location of food patches, for example, for several months. I think people have studied it in goldfish specifically because they have this 3-second memory, but that's just really not the case at all. And that's the case for many fish. They're capable of learning quite complicated things. They have quite complex social lives. I think the reason they get a bit of a bad press is because most people, when we see a fish, they see it in a small, goldfish bowl or flopping around on the bottom of the deck of a boat or something, for example. They're really not in their element. They're not. It's a bit like I don't know, having a rabbit but keeping it crammed in a cardboard box or something. Right? There's only so much it can do, and so it's not going to give a very good account of itself, sort of intelligence-wise, if it's kept in that kind of environment. And fish are hard to watch, right? Unless you go snorkeling or scuba diving or something, most people maybe catch a glimpse of a fish in a pond as it swims away. But you take animals like birds, for example, you can watch birds in your back garden and you can see them doing a whole range of quite complicated behaviors and having all sorts of social interactions with one another. I think fish are just that little bit harder to watch and some of that little bit less familiar, and so maybe we don't give them the credit that they're due.
So I guess we've debunked the famous phrase having the memory of a goldfish.
Absolutely,
That's maybe not as offensive as somebody maybe means it to be.
I mean, I don't think they're great. I'm not saying that they're geniuses, but just not they don't deserve a bad rap they get, I don't think.
Mike finished off by telling us a little bit more about some of the opportunities within Scotland to study animal behaviour and social behaviour further.
First of all, Scotland-wide has some really great departments, biology departments, where people are studying animal behaviour. So St Andrews certainly does, but Edinburgh, Glasgow, Stirling as well. There's really great research going on there and some really cool researchers and teaching staff. At St Andrews, we're very lucky. We've got quite a strong sort of cohort of staff who study animal behaviour. We've got research going on in a whole bunch of different domains as well. So the biology department there is roughly broken up into 3 departments, three kind of subsections. I'm in the one called the Centre for Biological Diversity, and there's research there going on and cognition and all sorts of social behaviours and conservation behaviour in a whole range of different species, from insects to birds, fish, and mammals. We've also got the Oceans Institute and the Sea Mammal Research Unit. So St Andrews is also a real centre of excellence for the research into whales and dolphins and seals, for example. And then there's a really strong sort of primatology cohort as well, mostly based out of the School of Psychology, where people are studying in the field, in places in different parts of Africa, as well as in zoos such as Edinburgh Zoo, where they're studying the behaviour of primates like chimpanzees and various monkey species too. So across the board, there's an awful lot of really interesting research going on into animal behaviour at St Andrews, and an awful lot of opportunity for people who want to study it further to come and study there.
Thank you very, very much for obviously your time, and hopefully, obviously, maybe some of the students that are listening will find their way to St Andrews and find themselves into your lecture hall at some point.
I sincerely hope so. That would be great.
Frans concluded by highlighting the importance of being able to observe and notice things when studying animal behaviour, and the need to separate feelings and emotions when studying animals.
There will be children who are now listening who are probably born observers. They exist, and they make excellent naturalists, because that's what a naturalist needs to do: watch very closely what's going on and ask the right questions. And so some people have that, and I think it would be good if they make use of that talent if they have it.
And of course, one of the most famous naturalists who had that exact talent, of course, would be Charles Darwin. And when Charles Darwin wrote his own diaries and from his observations, he talks very much about animals and their behaviours in quite human terms. And that's something that you do yourself. Why is it that in some aspects we quite often within science we seem to try and steer clear of relating animal behaviour and human behaviours to animals?
Yeah, it's interesting that Darwin wrote his book on. He wrote a book on the expression of emotions in humans and animals, and it's the only book of Darwin that disappeared for a whole century. And that is because in the previous century, we were not allowed to talk about animal emotions. And so the people felt that Darwin had gone too far and he had been anthropomorphic, as they call it, meaning he was applying human terminology to animals, which he shouldn't be doing as a scientist. And so now we are back to that book by Darwin because it's become very popular. Many people are studying animal emotions again. But it shows a little bit the taboos that we have faced in our discipline where you were not allowed to do that. And I think part of the problem is that people confuse emotions and feelings. And I think it's logical in human affairs that we conflate the two. Emotions are feelings and feelings are emotions. But I make a distinction. So feelings are private states that you only know for yourself. I know my feelings. You can describe your feelings to me, but for me, it's impossible to know exactly what you are feeling. Your emotions, though, are expressed in the body. Emotions are expressed in blood pressure, voice timbre, heart rate, all sorts of things. The emotions are always expressed in the body. And so emotions we can measure. And the emotions of a dog or a cat, I can measure objectively. What the cat feels, I really don't know. And it's very hard to know. And I can speculate about it, but that's all. And so I think if we make that distinction between emotions and feelings, we get a little bit ahead. And we get around that problem that people had with emotions.
I think it was Aristotle that once said that laughter was what separated us from the beasts, and that a baby might not have a soul until the moment it laughs for the first time.
Yeah.
Aristotle was obviously thought to be quite an intelligent person.
Well, I think Aristotle didn't know much about the primates, and that's of course a problem, is that if you only know camels or goats or whatever the animals are that he knew, or dolphins, you may not encounter laughter. But if you tickle a chimpanzee, yeah, they will be laughing. They make laughing sounds and they have a laughing expression on their face. And they have the tickle spots in the same places as human children do. And so, yeah, laughter is not uniquely human, and it's a play vocalization and a play expression in the primates that we see in all the primates.
Thank you so much for your time, Frans, and for speaking to our young people.
Okay, excellent. And good luck with it.
We hope that you'll have gained a wider understanding of social behaviour in animals during this episode, and you can hear more about social insects in our previous introductory podcast with Dave Goulson. By subscribing to the podcast on whatever platform you choose to listen, you can be sure you never miss an episode as we continue to cover the higher course over the coming academic year. Don't forget to check out our Twitter page @BiologyHigher for your chance to win free books to help you. And remember, you can get 40% off all Lecky textbooks, revision guides and practice papers using the discount code LeckyPodcast40 online at www.leckyscotland.co.uk.